Hi there, my name's Ross, and that's me. I'm your typical male inner city millennial type, uni educated software developer for many years now, and yes, I'm your typical millennial in that I've never owned a power tool, much less have I had space for my own tool shed. That said, in my formative years, I've learned a lot from working with my dad in his workshop and doing a lot of DIY things growing up, so I know my way around a Phillips head screwdriver if I need to. Sometime late last year came the problem. I found that people have made and make scale traction engines, like the proper real steam stuff. I instantly fell in love and started digging into it. And then more and more and more and more. I started digging into how things are made and how and engineering and tool making, and the rabbit hole ended like 6 months later with me needing to find a space to make myself a traction engine. Started a very soft target of about sort of 5 to 6 years from first chips of the first casting, but that'll slip and that's fine. Thanks to all these YouTubers you see here for sharing the knowledge and providing the inspiration to begin a hobby in model engineering. Thank you all. Naturally, links to all the channels are listed below in no particular order, so go check them all out. Back to the story. Conveniently enough, an ideal space came along at the right time. A secure 20-foot shipping container with power. Yes, sir. Soak it in. Look at that puppy. She's definitely been around a bit, so the inside isn't really a looker. Nevertheless, I've got that problem under control. Insulation, framing and paneling for the inside of this puppy. The plan is to just wedge the frames in without screwing them into the metal, so I don't have holes in the metalwork and no leaks. I've opted not to use vapor membrane because I've heard rust is like hedgehogs and something you need to create little homes for where you can. Bosh, there's some framing, nice and rough and ready. Bosch, some more Bosch. There we go, more framing. You can see the polystyrene insulation going in now as well. And here we go, you can see the proverbial, here's the one I made earlier. That stick on the floor there is important for what comes next. Here's a video, me walking around, giving a little bit of a tour and a little workman's knock on everything just to make sure it's all secure. Looks good to me. That's it, you read correctly. I got myself a Bridgeport Series 1 2J 2HP Varispeed milling machine called Betsy. Here she is being delivered from over 100 miles away. Love a good bit of machinery in the air like that. And look at that, lovely and spacious in her new home. As you can see, I've got my workbench back in there and set up, and you can see the metal I used to get the Bridgeport in on the work as my worktop there. As you can clearly see from this, and some other things I haven't shown you, the setup I've got is three phase and I need to be able to run it through 240 volts. So I need to get a VFD, and the one I landed on is the Tico L510. I won't spare you with the details of the specific one though. So that's my way forward. Right, you'll need to stick with me for this one. This is the transformer box on the side of the mill. So if you look at the key here, the purple is the motor and the forward reverse switch, and that will go off back up to the machine up the top to the reverse switch and the motor on the top. So what I can do is I can take this out and I can directly connect that to the Tico VFD and be able to run the mill all great gravy. Everything else in here is not needed to turn the mill on and off and forward and reverse. So that means this is the transformer, which was once for 20 volts. Now I'm going to wire it up to 240 or 220 volts, and then everything coming out of here is already 110 and whatever else. It doesn't matter because it's converting it down. I don't have to worry about that. So then that means the feed, the power feed, which is here, excuse me, I can leave wired up, and I can leave the light wired up. The isolator I'm taking out because I'm wiring the 240 directly to a plug. I didn't think I'd need it, because I need to unplug the plug to open it anyway. This is the last time you see some fine 80s style wiring before you see me get in there and butcher it up. It's a shame, really. Okay, so I turned it on, nothing blew up. I've programmed it, and the motor's banging, so I need to sort that out. The VFD took a little understanding to program, but once you got some confidence, it was easy to wire up and sort out first time, so that was good. Powering it up though, as you heard in that video, it brought about some new issues. Bearings and bushings in the head needed sorting. So I had to learn on the fly, take the head apart and find the problem. First problems were the bushings inside the pulleys. They needed replacing. Easy enough, they were sloppy. I then found out all the bearings needed replacing, and while I was there, I'll do the belt because the uneven wear of the bushings on the belt, that will wear that unevenly. So here I am, many pounds sterling later, with a 10-ton hydraulic press fitting new bearings like a champ. Turns out the pulley I had on the motor was the old type and they didn't do bushings for that anymore, but not to worry, as I could buy a whole new pulley for a couple more zeros on the wrong side of a decimal place. Either way, money well spent. I managed to get a strobe dyno on the phone so I could roughly get the speed accurate to however accurate speed like dyno app on your phone gets it, but it was running sweet. Low range, so it'll be on the slow speed. So let's do it. And that awful knocking's gone. Nice. First official chips. Yes, it was clamped down with some wood in the middle as well, yeah. I also managed to score a sweet free metal cabinet. It was slightly rusty, 5 shells to deal with, so I got the angle grinder out and cleaned them up. Then I whacked them back in and gave them a bit of a black spray paint. So now I've got the mill all sorted and running nicely, it was time to invest in the lathe. I was thinking about getting a new import style lathe directly from the manufacturer until I got a phone call about Colchester Master Series 1.5, 6.5 inch. I heard the story, saw the condition, and instantly got it delivered to me for half the price I was going to pay for a new import. So I'm a happy guy. She's called Cherry. Here you can see her coming in hot, and here she is dangling. Here you can see we've had to improvise our way over some construction work that I didn't know was happening. If you look at the other video, it wasn't there or happening at that time when the mill was arriving. So we got her in though, got her ready to go into position. I just need to get her leveled and powered now, but she's looking good at home. So next steps for me really, I've got to sort out the electronics for the lathe. Probably get VFD set up for that, so I've got variable speed as well as the gearing. I need to get a vise and some collets for the mill so I can actually start using that. And yeah, get making chips really. I need to buy some bar stock so I can just start cutting that down and get some threads and dies so I can start using taps and stuff. But yeah, I've got a shopping list that I need to that I've put together that I'm trying to work my way through purchasing, and I consider that the ultimate list of things you need to get a viable workshop going. So I've done pretty well working my way through that, and as you can see here, there's a quick screenshot of that list. I'll share the link to the list down below, and yeah, feel free to comment on it. Thanks for watching. Cheers.